Bismillah ar-Rahman ar-Rahim. Wassalatu wassalamu ala Rasulullah. Muhammad bin Abdullah wa ala alihi wa ashabihi wa mawala abad. Good evening, my listeners, my viewers, and my subscribers. This particular class at SWAP Academy on chemistry, it will be on separation techniques. And this particular class is mainly prepared. It's mainly prepared for JAM students, preparing for JAM, and also for WAEC students, or NECO and other form of exam. So please follow. Don't forget to like, share, and also subscribe on this. What is separation techniques? Is an aspect in chemistry that question do come out, especially in JAM, do come out in it. But before we enter all these particular areas, all these particular problems, we have to be able to, as a student, we have to be able to what? Segregate them. What do we mean by separation techniques? Separation. Then what is techniques? Now let's join them together. Note that when we say separation techniques, you can be jotting that down. We mean from the word separate, mean segregate, mean disintegrate, mean you divide, mean dissociate. You divide. This is y and this is x. Let me put it that. And y and x, they are together. I have to divide them together. This now is a mixture. Is a what? Mixture in chemistry. We have to make y to be on its own and x to be on its own. How are we going to do that? What topic is going to tell us that? It is this what? Aspect of what? Aspect of separation techniques that is going to aspect of this lesson that will tell us what we mean by that. Are we together? What is going to tell us this? That x and y is a mixture. What do I call it? Is a mixture, and we have to segregate them, meaning separate them. The reason I'm using segregate, separate, I don't want to use the same word, the same what the topic implies. That's why I'm using another synonymous word. Segregate, meaning divide through, which is x, and we'll be having y. What aspect of that in chemistry that will tell us how to make x to be on its own and y to be on its own is what? Separation what? Techniques. Now let's jot it down. What is separation techniques? In JAM class, you don't need too much of story. All you need is understand the topic. That's one way. You people that are finding it difficult, that I'm having less than a month, 2 months, and I'm preparing for JAM, how am I going to? You don't need to cram. All you need is just put down the key words and use your way of constructing them properly. When you have this keyword that you must, when you are defining this topic, the keyword must be there. Use your word. It could be defined, it could be explained, it could be reversed, it could be any cool, but put all the keywords. Now, what is separation techniques? A separation techniques, you can be jotting that down, is an aspect in chemistry that deal with what? The ways of segregating two or more mixture. Two or what? More what? Mixture. Two or what? Or more mixture. Through what? Through mixture. Through what? Through physical mix. Through physical mix. Now, what are the keywords there? Through physical mix. What are the keywords there? We have what? Mixture, and we also have a what? Physical what? Physical mix. That means in separation techniques, if you are doing it, if you are not, when we mean mixture, mixture is in chemistry, you know, we have elements, we have mixture, and we have compound, we have molecule. Don't forget, we have radical, we have a ion. We are still coming on that. Now but what matters most is when you are doing this topic, it involves what? Mixture. That is why mixture and physical techniques. Meaning is an aspect that has to do with the segregation of mixture through a physical mix. What do we mean by mixture? A mixture is the combination of what? Two or more constituents. Is the combination. If you can be getting the key word for this separation techniques is mixture and physical. Now I'm breaking mixture. you have to understand what is even mixture. Garri with water. Garri is a solute in chemistry class. Water is a solvent. When you pick garri, you added water to garri, it becomes a what? Solution. Meaning garri solute, water being a solvent, when you add them together becomes solution. How can you segregate garri? We want our garri back. We want our what? Water back. This aspect of feed is going to tell us on how to get that. Now, that's water and garri. That is the common example. It's now what we call mixture. Are we together? And know that the mixture, when we are defining mixture, is the mixture. I know you can. You are talented. You can be putting it down. Mixture means the what? The combination of two or more constituent. This is constituent. And constituent as a whole means two things. Constituent can be element, element now, and can also be what? Compound. The combination of element and compound, it might be element alone, it might be compound, or the combination of both is what we know as constituent. Then the constituent is what is forming mixture. That means without constituent, without element and compound, we can't have constituent. Without constituent, we can't have mixture. Are we making sense? That means E plus C, element plus compound. That means E plus C, element with compound, E plus C gives what? C, which is the constituent. Just for you to understand it. You don't need to cram, just understand. Element plus compound gives what? Constituent. Constituent now is what is giving what? Mixture. And mixture now is what lead to what? Separation what? SP. Separation techniques. S what? ST. That means for this topic, to be this topic, there must be E, C, C, M, S, T. Are we together? This standing for element, compound, constituent, mixture, separation techniques. Are you with me? So that is that under that. Now let's recap our statement. That means mixture, now let's divide it based on this. Mixture is the what? Is the combination of two or more constituents. And the constituent might be the element or might be compound. When I say element, I mean oxygen is an element. Sodium is an element. Calcium is an element. Then when I say compound, so mixture, when I say compound, we simply mean like CO2, carbon dioxide. Like what? Like CaO, quicklime. In chemistry, H2O. You can still say H2O, water. All these things are compound. Is different from element. So the combination of two elements forms compound. That means the combination of elements forms compound. And compound element of the same nature gives molecule. A molecule can also be atom of different elements. Let me recap that. When we are defining element, we say element is a substance which can be, I know you will have, the reason I'm not going to there is because of this topic. I want us to quickly round it up. But in as much, let's just brush that. What is even element? We have finished mixture. And mixture is what we truly need here. What is element? Element is a substance which cannot be split into two or more simpler forms. Are we together? By any ordinary chemical reaction. What is element? Example is ordinary oxygen. This is an element. What follows? Hydrogen. And all these 20 elements and more than that. Neon, mercury, silver, and many more. Bromine, they are all elements. Now, what is compound? When I'm now adding H with O, with another O, making what? H2O, which is this, is becoming compound. Thus, the combination of two or more elements is what form compound. Did you understand here? Now, when we will now combine this and this becomes constituent, which we are saying. Then the constituent is what is inside mixture. Are we? So our mixture, now let's bring it back to the environmental incident that you quickly get. Now, look at, in our environment, we can't do with one mixture. What is the mixture? Air. Air is a mixture. Air. This air. This air. In Yoruba, we call it afefe. Air is a what? Is a mixture. Mixture of what? In air, we have carbon. In air, we have oxygen. In air, we have carbon dioxide. In air, we have nitrogen. Are we together? All this, nitrogen is an element. Can you see that? Carbon dioxide is a compound. Can you see that? And in air, we say air is a mixture. That means in air being a mixture, it contains what constituent, which might be element or compound. What is the element that is there? It is ordinary nitrogen. You know, nitrogen is there, which is 78 degree. Oxygen is also there. If nitrogen is 78 degree, oxygen will be lesser. That's why when you light up a matches, you want to light up a candle. You light it up in an open space. You will see that that candle, when you light it up, it quickly go off. It's as a result of the what? High degree of nitrogen present in it. So why? Let me come back. Nitrogen now is a what? Is an element. Now carbon is an element. But CO2, is it an element? No. It's a compound. It's also there. Now, either an element or a compound. Both are what now? Air, which is the mixture. Are we together? Like the same thing, milk is also mixture. It contains some what? Some nutrient or some plant nutrient, which form milk. Some animal nutrient, which form milk. We have even soil is a mixture. An example, we have the clay soil, we have the sanding, we have the loamy, humus, and so many things there. So that's just mixture. So now let's go back to this. How can we segregate? Through physical means. Through physical means that we need to separate them physically. Physically means what you can see. It is not theoretical aspect. You must be practicalizing it. That's why they define separation as the techniques which have to be with what? The act of segregating two or more mixture through physical means. What is physical means? Knows that each physical types of physical means. That's what we want to enter. Types of what? Physical what? Types of what? Physical what? Physical means. Types of physical means. That's another key point. I think I've made myself clear in mixture. Now physical means. These are the key points that comes together to form this separation thing. Now note that you can't just apply. I said Gary with water. You can't just apply any physical means to separate that. Each one. Ink with water. Water with petrol. All these things. Chalk with water. All these things. It has a way of what? Well, ethanol with water. It has a way of segregating them. It has their own physical means. You can't just put anyhow. How? The physical means. JAMB can ask you, what are the conditions depending on how we know what each constituent will fall on, what physical means for each constituent. What are the conditions guiding each constituent passing through one physical means or the other? That means each mixture, it contains constituents, right? And each constituent, now you can't just apply any decantation, sieving, you can't just apply anyone. It has to follow some practice. What are the physical means? Firstly, note that I do denote it as SBS R square. And if you are reading, you have to be doing all these things. You have to be noting that. This S stands for what? This S stands for solubility. How soluble one is to another. Gari and water. Which one? Gari and something, or one with other. Which one quickly dissolve? When we look into that solubility, then we know what physical means. Is it decantation that is fit in for that? Filtration, fractional distillation, chromatography, sieving, and many more. So this or sublimation. That is this. You have to check the solubility. So JAMB now can ask you, what are the physical means that each constituent depend on? Just know that it is SBSR squared. S stands for solubility, solubilities. What follows? B stands for boiling point. the rate at which one boil over the other. You know, if I mix water with ethanol, water boil at 100 degree, ethanol boil at 78 degree. Which one will quickly vaporize? Ethanol will quickly go soft. The steam will quickly go soft when you are eating it. So that means ethanol will quickly go up, then we quickly take ethanol through what we know as, we are still coming in there, through what we know as Liebig condenser. We still draw the structure. So it depends on their boiling point. Each boiling point determines what physical means you are going to apply. Are we together? Now what follows? S, sublimation. When we mean sublimation, we simply means when a substance move rapidly from what? From gas state, from solid state to gaseous state without passing through the liquid state. You know, we have how many states of matter? We have the solid, we have the gas, and we have the liquid. Please read on that. Solid, when a substance moves directly from solid state to a what? To a gaseous state without passing through a liquid state, is what we know as sublimation. It also depends. Like camphor. When you put camphor into your cupboard where you keep all your wardrobe material stuff, you will see by the time you are checking it consistently, you will see that the camphor will be what? Will be reducing. It's undergoing what we know as gaseous state. The gaseous state is reducing. When you check it in 1 month time or 3 weeks time, you won't meet the camphor there. Camphor is from what? Solid. To what is it moving to now? To gas. Will you see your cloth met with water? No. Is that going to be liquid wetty material in your cloth? No. It moved directly from solid to what? To gas. That's what we mean by sublimation. Are we together? And we have rate. Rate of what? Rate of how is a substance move in an absorbent medium. Absorbent what? Absorbent medium. Are we together? Or magnetic medium. How, you know, when we have a color, we insert a paper here. Paper inside that color, we call this paper. JAMB will ask you, what is the name of this paper? They can call it X. This paper is what we know as what? This paper is what we know as, you inserted it inside this. This paper is what we know as chromatogram. Chromatogram paper. So when you insert it, maybe it contains black, red, yellow. You want to separate them. When you insert this, you put a jar. It is there in the gas jar. When you do that, when it gets to one point here, we have the original spot. When you get into this, red and white, everything will become separating in that paper. On getting here is called solvent front. JAMB will now ask you, this is labeled as what? This is labeled as S. Use it to answer question 1, question 42 and 45. This one that is labeled as S is, what is the name? We call it solvent front. This one is labeled as Y. What is the name? We call it original spot. Then this one labeled, that is how JAMB do. You just have to get their what? Their logic. Are we together? Now we mean rate of absorbance and rate of what? Rate of chemical reaction. Rate of chemical reaction. Rate of how they what? They react. How they react, their reactivities. It also depends. That's why we make it SBSR squared. Are we together? These are the properties, ways of determining which physical means we are going to apply. Are we together? Now, if you find this very helpful, don't forget to like, share, subscribe, share to the needies. They will also pray for you to try and do so. So we have made mention of SBSR squared, which is solubility, boiling point. This is sublimation, rate of diffusion, and we have rate of what? Rate of absorbent medium. How each move. When some get to certain point, they separate. Red goes to red, blue goes. There is that on this. Now, types of physical means, which is types of what? Separation techniques. One, we have sieving. We have what? Sieving. I think this is sieving. We have sieving. When we say sieving, not the key point there is that sieving happens to be a separation technique which separates solid particles of different size. That is just the key word. Solid particles. Particles of what? Of different what? Different what? Different what? Size. So a separation technique that has to do with separating particles, and that particles must be solid of different size. We make use of sieving. So JAMB can ask you, dash is an aspect of separation techniques which separate particles of solid, particles of different size, mainly solid. We call it sieving. Now, the best example is this Gari industry. When they do Gari, you will see that in that Gari they have different sieving nets. That's different sieving net. In that sieving net, we have some if this is a sieving net, if this is a sieving net, if this is a sieving net, and they want to the processed Gari, they will put it inside that sieving net. They will start sieving it. The bigger one will stay on top of that mesh. The smaller one we pass through to the bowl that they put. We pass through. This one that pass through the bowl, it is particles of one size. The one in the sieving net, it is particles of what? Another size. So we don't use sieving net, which is sieving method, for liquid material. That is one physical name. We use it for what? Solid particles, which is example this Gari. When you put Gari here, the lighter one will come down. The bigger ones, the lumps, will be on the top. Then you will have Gari. That is the ways of separating Gari with different solid of different sizes. Are we? Now, if you are getting that, let's move to what? Let's move to decantation. That is good. That JAMB can ask you that the art of separating particles, liquid solution, liquid particles, lighter particles from denser particles is what? We call it decantation. What? It is not incantation. No. It is decantation. So decantation in chemistry, we mean the art of separating, is a separation technique which involve art of separating a lighter particles from denser particles in a what? In a liquid solution. These are the keywords to know. Lighter from denser. Meaning Gari, let me still use Gari. Gari coupled off with so many dirty and with so many things on it, and you want to take that Gari. What method as a chemistry student you apply? You will add water to it. You know, all this lighter particle, all this rubbish that is not Gari, what do? They will come up. They will pop up. The denser one, the main Gari, will goes down inside the cup. The lighter one will come. Then what are you going to do? You will now carry the solution. You will now be what? You will be pouring the what? The lighter particles, which is on the top. You will be pouring it into one bowl. Then the denser particle will be inside the cup. Meaning, what do I mean by that? If this is the bowl, if this is the bowl, and if this one, let me come to this side. We are under decantation. If this is the bowl, and this is another bowl, which is the mixture, I mean the Gari mainly, with all these rubbish things inside, and you want to do that, add water to it. When you add water to it, that one, the lighter one will go up, which is not Gari. The other one, which is Gari, will remain on it, on the bottom. Then you carry your what cup, start pouring it with the lighter one. The lighter one will be coming to this one. Then you have your Gari. That means your main Gari inside this cup. This, you call this one, we call it decantation. Then JAMB can ask you that this one is called what? This one is called what? Now know that all these things are all what? This is this here is the solid. We call it solid one. This one that is one, we call it liquid, which is inside there. The both are called mixture. Are we together? So now the one that pop up is the lighter material, which is the one that is pouring. The lighter what? Lighter material. The one that we don't want. And the one that remains which is the substrate, with filtrate. Let me use it in that manner. Or substrate. Well, let me use it in that manner. The one inside this cup is what we call the what? We call the denser one. That is why a methods which involve the separating of lighter particle from a denser particle is what we know as decantation. That's what I want you to get. But note, they can ask you difference between decantation in JAMB and filtration. Which one is the best method in chemistry? Which one is best most? Know that the one that is best most is filtration. Filtration is more reliable than what? Decantation. Because decantation, as you are pouring it, the one that you need, which is the denser particle, might agitate. Might be popping up as you are pouring it. This might be, the medium might be getting troubling. When you are pouring the lighter one, the denser one that you need might be pouring as well, because of the wave that is disturbing it. That's why this method in chemistry is not better than that of filtration. Filtration is also more better than this. So JAMB can ask you difference between filtration and which one is best. A, decantation is the best. B, A and B. C, none of the above. You know what to pick. Filtration is more better than what? Decantation. Both are applying the same way, but filtration is more. Now let's go to filtration. What do we mean by filtration? Filtration is the means of separating insoluble particles from a liquid solution. Insoluble particle from a what? Liquid solution. Meaning the insoluble particle, the particles that when they enter a solvent medium, they can dissolve. They didn't dissolve. They become, we call it in chemistry, we call it insoluble. How do we separate it from a liquid solution? We use filtration method. And through what? Through a filter pour. We call it filter paper. Through a filter pour. The same thing. Another method is when I'm having, if this is a tap, normal tap that we use in our garden, and the water that is coming, the water maybe is coming with a particle that is unwanted, you can tie up a Muslim cloth. This Muslim cloth is all called that one with a tiny hole. We call it Muslim cloth in biology. So you just tie it. When the water is entering this, the dirty will be on this Muslim cloth, and the remaining water will be coming here. This water that is coming here is what we call filtrate in chemistry. Why this one, the dirty that remain on this Muslim cloth, is what we know as the what? Residue. Are we together? So the reaction between the residue and the filtrate is what we know as this process is what we know as filtration. Please don't forget to like, share, and subscribe. ASOP Academic Online Class. If you are still troubling on one subject or the other in science courses, don't forget to drop it in the comment section or in the comment platform. I still remain my humble servant, Akorede Oluwayinka Hassan. ASOP Academic. Stay blessed, more blessing. Have a blessed day.